Article 86 addresses the number of bends allowed in a conduit run between pull points, such as boxes, fittings, or other access points. The purpose of this limitation is to prevent damage to conductors during installation and to ensure that conductors can be pulled easily and without excessive strain. Excessive bends increase the pulling force required, which can damage the conductor insulation, leading to premature failure or creating a hazardous condition. The maximum number of bends permitted between pull points is equivalent to a total of 360 degrees. This means the sum of all bends, including offsets and any other deviations from a straight line, cannot exceed 360 degrees. For example, this could be 4 90-degree bends, or 2 90-degree bends plus 4 45-degree bends, or any other combination that adds up to 360 degrees. It is important to consider that this is a maximum limit, and in many cases, it is preferable to use fewer bends whenever possible to reduce pulling stress and improve the long-term reliability of the installation. Bends are typically created using conduit benders, which come in various sizes and types depending on the type and size of conduit being used. Proper bending techniques are essential to avoid kinking or flattening the conduit, which can reduce its internal diameter and make it difficult or impossible to pull conductors through. When planning a conduit run, it is crucial to carefully consider the route and minimize the number of bends needed. This may involve rerouting the conduit using larger pull boxes or strategically placing access points. In situations where the 360-degree limit is unavoidable, it may be necessary to install intermediate pull boxes to break up the conduit run into shorter segments with fewer bends. Selecting the correct type and size of conduit is also important for minimizing pulling force. Smoother interior surfaces and larger diameters generally make it easier to pull conductors. Lubricants specifically designed for pulling electrical conductors can also be used to reduce friction and make the pulling process easier. The NEC also provides guidelines for calculating conduit fill, which refers to the amount of space occupied by conductors inside the conduit. Overfilling a conduit can make it difficult to pull conductors and can also lead to overheating. It is important to consult the appropriate tables in the NEC to determine the maximum allowable fill for different types of conduit and conductors. The NEC also addresses the minimum bending radius for conduit. This is the minimum radius to which conduit can be bent without causing damage or reducing its structural integrity. The minimum bending radius depends on the type and size of conduit. Exceeding the minimum bending radius can cause the conduit to kink or flatten, which can restrict the flow of conductors. It is also important to consider the type of conductors being used in the conduit. Some types of conductors are more sensitive to bending and pulling stress than others. For example, conductors with thicker insulation may be more resistant to damage. The NEC provides specific requirements for the types of conductors that can be used in different types of conduit. In addition to the 360-degree bend limit, the NEC also includes requirements for the support and securing of conduit. Conduit must be properly supported to prevent it from sagging or moving, which can put stress on the conductors and connections. The NEC specifies the maximum spacing between conduit supports, which depends on the type and size of conduit. The NEC also requires that conduit be securely fastened to walls, ceilings, or other structures to prevent it from being dislodged or damaged. When working with electrical conduit, it is important to follow all applicable safety precautions. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and energizing circuits before working on them. It is also important to be aware of the potential hazards associated with working around electricity, such as electric shock and arc flash. Proper training and experience are essential for working safely with electrical conduit. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is important for electricians and other electrical professionals to be familiar with the NEC and to follow its requirements carefully. Failure to comply with the NEC can result in fines, penalties, and even legal liability. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date with the latest version of the NEC to ensure that electrical installations are safe and compliant. The NEC is not a substitute for proper training and experience. It is essential for electricians and other electrical professionals to receive adequate training and to gain experience under the supervision of qualified professionals. The NEC is intended to be used in conjunction with other applicable codes and standards such as local building codes and fire codes. It is important to be aware of all applicable codes and standards when designing and installing electrical systems. The NEC is a valuable resource for ensuring the safety and reliability of electrical installations. By following the requirements of the NEC, electricians and other electrical professionals can help to prevent electrical hazards and protect people and property. The 360-degree bend limit is a critical aspect of ensuring the safe and efficient installation of electrical conductors within conduit systems. Adhering to this regulation minimizes the risk of conductor damage during pulling, maintains the integrity of the insulation, and facilitates future maintenance or modifications to the electrical system. Ignoring this rule can lead to increased friction, difficulty in pulling conductors, potential damage to conductor insulation, and ultimately, a compromised electrical installation that may pose safety risks. Furthermore, exceeding the bend limit can result in violations of electrical codes, leading to fines, rework, and potential liability in case of accidents or failures. In addition to the bend limit, factors such as conduit fill, bending radius, and the type of conductors used also play a significant role in the overall performance and safety of the conduit system. It is essential to consider these factors in conjunction with the bend limit to ensure a well-designed and compliant electrical installation. Proper planning, careful execution, and adherence to relevant codes and standards are crucial for achieving a safe and reliable electrical system that meets the needs of the application while minimizing risks. It's also worth noting that certain types of conduit, such as flexible metal conduit, may have different bend radius requirements or restrictions and the total number of bends allowed due to their construction and intended applications. Always consult the manufacturer's specifications and relevant sections of the NEC for specific guidelines related to the type of conduit being used. Regular inspections and maintenance of conduit systems are also important to identify any signs of damage, corrosion, or excessive stress that may compromise the integrity of the system. Addressing these issues promptly can prevent potential problems and ensure the continued safe and reliable operation of the electrical system. Remember, the 360-degree bend limit is not just an arbitrary rule, it's a fundamental principle aimed at safeguarding electrical conductors, promoting ease of installation, and ensuring the long-term performance and safety of electrical systems. By understanding and adhering to this regulation, electrical professionals can contribute to creating safer and more reliable electrical installations for homes, businesses, and industries. The NEC regulations regarding conduit bending are based on years of experience and research, reflecting best practices for electrical installations. Compliance with these regulations is not merely a matter of following rules, but a commitment to ensuring the safety and functionality of electrical systems. Furthermore, the NEC provides guidance on the selection of appropriate conduit types and sizes for different applications. Factors such as environmental conditions, mechanical stress, and the type of conductors being used should be considered when choosing conduit. Using the correct type of conduit can help to minimize the risk of damage and ensure the long-term reliability of the electrical system. In addition to the 360-degree bend limit, the NEC also specifies requirements for the grounding and bonding of conduit systems. Proper grounding and bonding are essential for preventing electrical shock hazards and ensuring the safe operation of electrical equipment. The NEC provides detailed guidance on how to properly ground and bond conduit systems, including the use of appropriate grounding conductors and bonding connectors. The NEC also addresses the issue of corrosion in conduit systems. Corrosion can weaken conduit and reduce its ability to protect conductors. The NEC specifies requirements for the use of corrosion-resistant materials and coatings in areas where conduit is exposed to corrosive environments. The NEC also provides guidance on the proper installation of conduit in hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. The NEC specifies special requirements for the types of conduit and fittings that can be used in hazardous locations, as well as the methods of installation. The NEC is a living document that is constantly evolving to reflect changes in technology and best practices. It is important for electrical professionals to stay up to date on the latest version of the NEC and to understand how its requirements apply to their work. Continuing education and training are essential for ensuring that electrical professionals have the knowledge and skills necessary to perform their jobs safely and effectively. In summary, the 360-degree bend limit in conduit runs is a crucial safety measure designed to protect conductors and ensure the long-term reliability of electrical systems. Adherence to this regulation, along with other relevant NEC requirements, is essential for creating safe and compliant electrical installations. Continuous learning and a commitment to best practices are vital for electrical professionals to stay informed and contribute to a safer electrical environment.